toward this. All right, if x minus 1 over 3 equals k and k equals 3, what's the value of x?
10.
Good. Number 2, if you clearly know them, I won't spend a lot of time on them.
Okay.
Okay? We'll only stop if you have problems with it.
Okay.
Okay, number 2, this deals with imaginary numbers and complex numbers. Have you had those?
No.
Well, it's actually rather straightforward. They're telling you, hold on, let me get this screen. They're telling you that I, the imaginary number, equals the square root of negative 1. Okay?
Okay.
What's the sum of 7 plus 3i plus negative 8 plus 9i? Well, what would you think you would do?
Do you just
Add the real parts, add the imaginary parts. That's it.
Yeah.
That's it.
Okay, so it'd be negative 1 plus 12i?
Uh-huh. That's answer A. Yeah.
Okay. I'll keep that in mind.
Yeah, it's very, you wouldn't want to miss a problem like this because it's
You just don't mess with I, you kind of just simplify, I guess.
well, yeah, it can get a little more complicated where you can multiply. In other words, if I was multiplying these two things together,
You have to go I squared.
well, you would FOIL it, first of all. You would end up with an I squared, and guess what? I squared equals minus 1.
Yeah.
So I squared is no longer a complex number. It's a real number. It's minus 1. And so whenever you encounter an I squared, substitute minus 1 for it. If you have just i's, then you got to leave it like that. In other words, there's nothing I can do to that answer A. That's as simplified as it can get.
Okay.
All right, how about number 3?
Okay. Is M just anybody? Oh, M is the
M is a variable.
Yeah, it's the amount of messages.
Yeah.
Okay. 5 hours. 4 hours. I guess it'd be C.
Correct. However, let's talk about this problem, because this problem illustrates a principle that is really key when you're taking the test. And that is, occasionally, you're not going to be able to figure this out. This wasn't too bad because it was all multiplication and addition. But throw in another variable there that needs dividing, and it can get very confusing. Okay? So there's a thing you look for. And what you look for is when you have variables in the statement and the same variables in each answer. In other words, we're looking at an M and a P in the problem, and we're looking at M's and P's in every answer. Well, what that means is you can let M and P be any numbers you want. And this method is called picking numbers and then back checking. Let me show you how it works with this one. I'm going to pick an M of 2. How many messages did Armand send?
2 text messages each hour, 10.
Okay. And I'm going to put a P of 3. How many did Tyrone send?
Tyrone sent 12.
Okay. Notice that by picking numbers, we can easily figure out what the right answer is supposed to be. 22, right?
Mm-hmm.
Well, now, if we go through each answer and plug in 2 for M and 3 for P, which one is 22? That's the answer. Notice that the first one is 54. That's not right. The second one is 120. That's not right. The third one is 10 plus 12, 22. The fourth one is 8 plus 15, 23. So I figured out the answer without really, you see what I mean by picking numbers and then checking each answer to see. Usually when you pick numbers for these variables, you know how to figure out the answer. In other words, once I picked 2, well, you knew that Armand sent 2 times 5, right?
Yeah.
And you knew that intuitively. So it was not hard to come up with 10, and it wasn't hard to come up with 12, which means we knew the correct answer was 22 for these 2 numbers. Now, M and P can be anything you want.
Yeah, I just put them as 1.
Yeah, what this tells us is that we're going to check each answer until we find one that's equal to 22. Okay? That's picking numbers and back solving.
Okay.
But number 4.
Okay. Kathy's it's B.
Correct.
Because she does 23 per day, so yeah, it's pretty simple.
Yep. No, you're correct. Okay, now we get into more algebra type problems. Number 5. So the secret on number 5 is, first of all, remove the parentheses, all of them. Then collect like terms. Okay? The first set of parentheses I don't need in the first place, right?
Yeah.
In other words, they don't really accomplish anything. The second set do, because they're being subtracted, which means for me to remove the second set of parentheses, what do I have when I remove them?
You're subtracting the entire thing.
That negative sign's got to be applied to every term.
Yeah.
So what do you have? Comes plus x squared y.
Okay.
Keep going.
I don't even know.
Okay, apply this negative sign that I'm pointing at, the subtraction. Apply that to each term. Well, when I applied it to the first term, it turned into a plus x squared y.
Okay, so then minus
there you go.
3xy squared plus 3y squared.
Correct. Okay, now we can combine stuff. In other words, we've got 1 of those, 5 of those, 1 more of those.
You're just combining like terms then?
Yep, that's all we're doing, is we're looking for all the terms that are the same. In other words, it's got to be specifically an x squared y. In other words, an x y squared is not a like term. Okay?
Yeah.
So I've got 7 x squared y's, and just cross them out as we deal with them. Why did I think I had 7? That one's not 1. Okay, I was misreading it. We got 6. In other words, we got 1, we got 2. My apologies.
Yeah, I was like, wait, what?
I bet. Nothing like confusing the issue, huh?
I was like, where are they all coming from?
Okay. Now let's take the very next y squareds. How many of those do we have that are y squareds?
Just y squareds?
Uh-huh.
Well,
By themselves.
one,
In other words,
two,
well, we've got
just
two of them, but they cancel each other out.
uh-huh.
So we don't really have any. And the only term left are these x, y squareds. And how many of those do we have?
Two?
Yeah. In other words, we're combining that term and that term.
Yeah.
Which gives us 2xy squared. And that's everything. There's nothing else there. So that's our answer. And that's number C. Yeah. So notice that if we were adding instead of subtracting, then I could have just removed both sets of parentheses without affecting anything.
Uh-huh.
It's only when you're subtracting that this second set of parentheses is extremely important, because that means that subtraction goes to every term.
Yeah.
I can't just erase those second set of parentheses. I don't have the right numbers if I do that. All right. Number 6.
What is the estimating percentage of what's like each year? 3A.
Yeah, the slope. In other words, if I were to graph that, that's linear, height being that axis, and it's got a slope of 3. Well, that means every time he goes a year, he gains 3 inches. Rise over run.
Mm-hmm.
Okay. The next one is one of my favorite problems on here.
Okay.
Looks nice, doesn't it? Number 7.
At first glance, it looks a little complicated.
Okay. I don't blame you for saying that. That's their intent. Their intent is to make it confusing.
Yeah, okay. Let me read it.
Okay.
Formula gives the monthly payment needed to pay off a loan of dollars at 5%.
This actually is very illustrative of SAT. They go out of their way to confuse you. We don't care what P is. We don't care what R is. We don't care what N is. We don't care what any of those are. This is a straight algebra problem.
Well,
if I told you that M equals A times B divided by C to the nth minus 1 all times P, how would you solve that for P?
Well, how would you solve? Oh, it's
yeah. In other words, I want that to be all by itself. How do I get rid of the A, B, C, and 1?
Or divide by them?
Well, you multiply by the denominator.
Yeah,
So
okay, yeah.
M times C to the n minus 1, and you divide by the numerator. And that's equal to P. It's as simple as that.
Yeah, it's like changing. Yeah,
what this problem does is tries to confuse you by putting these really complicated terms in place of A and B and C. This is one of those problems where I'm sure there's a lot of people that dive into the algebra here and try to multiply these two together and try to find a common denominator. You could spend 30 minutes on this problem trying to do that.
But in reality,
the
you just kind of got to
reality is
rearrange it.
it's a simple algebra problem. So what is P equal to here?
P is equal to A.
Yeah. And you didn't have to do any math at all.
Yeah.
All you had to recognize that is we were going to multiply by the denominator, we were going to multiply m by the denominator, and then we're going to divide m by the numerator. And so everything stayed the same. This was actually a very easy problem. And yet, I guarantee you, 9 kids out of 10 would look at this and say, this is double check mark, I'm coming back to it later. When in reality, it really was not a hard problem.
Yeah. You just got to kind of know like how to...
Well, be aware that they're trying to trick you. They are. They put information that's not relevant into some of these problems. They do. Their goal is not to make it easy for you. It's to try to confuse you. So if A over B equals 2, what is 4B over A equal to?
A over B. 2. 1 second.
Let me give you a hint. Figure out what B over A is equal to.
If A over B is equal to...
If A over B equals 2, what is B over A equal to? Well, and the way to answer that...
Don't I just... Isn't it...
Solve that by multiplying by B and dividing by A. Okay. So that gives us 1 equals 2B over A. Now divide both sides by 2. And so you get B over A equals 1/2. Which makes sense. The easier way to do it is just to flip. In other words, draw your 1 under there, and B over A is going to be 1 over 2. Now that you have B over A, what is 4B over A?
4 over 2. It's 2.
Correct. In other words, I'm going to substitute 1/2 for B over A. I got 4 times 1/2, so it's 2. Okay. Have a look at 9, systems of equations. We want you to solve this for x and y.
For this, I just plug in until I got an answer. So I guess I'll start with a...
You mean you're going to back solve it?
Yeah.
I have no problem with that at all. I love back solving. Not sure that it's always the fastest way to do things. In other words, it's going to take you a lot of arithmetic if D is the answer, right?
Yeah.
In other words, if D is the answer, you got to plug this into that equation, make sure it works. Plug it into that equation, make sure it works. Of course, if it does, then you've got your answer. It's A. But if it doesn't, you're going to end up doing a lot of math before you find your right answer. Let me indicate a much faster way of doing it.
Okay.
Notice that I wrote the second equation with the x in front. Got to put a negative sign there and a plus sign there. And the y second. The reason I did that is because I want to solve this by elimination. Okay? In other words, I'm going to take this second equation and multiply each side by 3, giving me a 3 there, a 6 there, and a minus 57 there. Now, if I add these two equations, notice that the x variable gets eliminated. That's why it's called elimination. and I end up with 10y equals minus 80, y equals minus 8. Now, I could easily plug that into either equation and also get x, but we might not need to. There's only one answer on there that has minus 8 for y. So, it feels to me like this was much less math needed than back solving would do. Back solving, you'd still probably, well, I don't know, you'd have reached B by about the same time I reached B, and you would have seen that both answers work for both equations. And as long as you don't make a mistake, part of the problem with doing it your way is there's so much math and arithmetic that you got to do that it would be really easy to make a mistake. Right? I mean, particularly when you're plugging this into this equation, you got to make sure you plug the minus 8 in for the y and the 3 in for the x. And when you plug it into the first equation, it's the reverse. You got to put the x coordinate first, the second one, the y coordinate second. But if you did it my way and you came up with y equals minus 8, you're done. You do not want to spend the time checking it. This is a speed test. You're going to have about a minute, I believe, a minute per problem. And so you do not want to waste time doing stuff that you're relatively certain of. It's not like a test in class where you got all the time in the world and maybe you would check your answer. So be careful about spending more time than necessary with some of these problems that are basically pretty easy.
Okay.
This one, g of x equals ax squared plus 24. And g of 4 equals 8. They want to know what is g of negative 4 equal. Well, first of all, when I put something in the parentheses other than x, what am I supposed to do with it? How do I evaluate them?
You plug them in for x.
Okay. So if g of 4 is 8, it's also a times 4 squared plus 24, right?
Yeah.
Well, what is that? That's 16a equals minus 16. A equals minus 1. Now that we've solved for a, go back in and put that minus 1, and now solve for g of minus 4. In other words, once I've solved for a, I can now solve for g of minus 4. What is that going to be?
You have to...
Very important to take whatever is in this and put it in parentheses in place of x. So I want to put it in like this. That square does not apply to that leading negative sign.
Yeah, okay. So
what's that equal to?
It is just negative 16 plus 24, which is
Also
8. Yeah.
Also
8.
Yeah.
Okay.
And I suppose, now that I look at that problem, the fact that we're squaring x means it doesn't really matter if I have a positive or a negative number in there. It's going to be the same answer. Correct?
Yeah, since a is negative 1.
Which means if they tell us that g of 4 is 8, I know g of minus 4 has to be 8 also.
Oh, so you could just figure that out.
Let me explain a little bit more here. If I said this, and you say, well, g of 4 is 16, I know that g of minus 4 is going to be the same answer. It has to be, because when I plug minus 4 in there, the minus part disappears because it gets squared.
True.
So I can instantly say it's 16 without even doing the math. And that's basically what we're looking at here, a little bit harder, in the fact that they introduced this a constant.
Yeah.
But the fact is that a is not being squared. So the only difference between g of 4 and g of minus 4 is substituting either 4 or minus 4 for x, and they both come out to be 16. Which means g of minus 4 has to be the same as g of 4. And that's the other thing the SAT tends to do, is they put little shortcuts. If you happen to recognize stuff like this, then you can do the problem in 10 seconds instead of 30 seconds. In other words, there was the hard way to do this problem, and then there was the easy way of recognizing, because it's an x squared, not an x cubed, then the negative number has to give you the same answer as the positive number. And that really would have saved you maybe 20 seconds. And that is the secret of the SAT, is figure out how to recognize when there's a shortcut and how to do it.
Okay, well, I guess our time's up.
Yeah, I'll let you go. Good luck on your test.
Yeah, I'll probably definitely do better.
Well,
at least
we have
a little bit of...
We have a session scheduled for Thursday also. Your test is tomorrow or Saturday?
Tomorrow.
Tomorrow, okay. Well, I guess we won't be working on this Thursday.
Yeah,
But
on Thursday, actually, whatever we learn on school, whatever we learn in school that day, I'll bring to the table. Whatever we learn during class on Thursday, I'll bring to the table.
Okay, that's what we'll work on. Sounds good.
Okay.
Dominic, talk to you Thursday.
Yep, have a good day.